Okay, good afternoon, everybody, or evening, or morning, or, if you're watching this right before class, you really should have done this beforehand. All right, we are talking about circuits, and what I want to do today is kind of give you a little background in terms of what we're going to be looking at in this lab, and just talk you through a little bit of the equipment that you use in looking at circuits. So, start off, let us talk about our friend, the digital multimeter. This is our friend, the digital multimeter. It has two leads, positive lead and a negative lead. The only reason that we care about making a distinction is so that when we get a number, the number has the sign that we expect. So for example, if I come over to a battery, and I want to measure voltage, and I'm setting this thing up to measure DC voltage, which I realize is probably very hard to see, but so it says. And I measure it against the battery. I put the red, the positive, at the positive terminal, negative at the negative, and I look and I see my hand. I look and I see still my hand. All right. Turns out really hard to do camera work. 1.47, roughly the voltage of a C-cell battery, which if we look at the marker here, it is in fact rated at, I'm sure it's totally legible, 1.5 volts. Hopefully it's not as blurry for you as it is for me. Now, in looking at this is a digital multimeter because it has a ton of options. Up here in the top corner, we have DC voltage. So it can measure voltages from 200 millivolts, 2000 millivolts, so 2 volts, 20 volts, 200 volts, 1000 volts. High voltage for this. If it reads a value higher than this, it'll max out and just, read blank basically. So the reason I do this is so you don't fry the electronics. Basically, it's sensitive up to a certain volume. You can also measure AC voltage. You can test batteries, which is probably what I should have been using to test a battery. You can measure DC current, making this an ammeter. You can measure high current situations, which requires you to put the plug into a different outlet. All right, I will admit I don't know what that one means. That's a diode tester, I guess. That's kind of weird. And you can also measure resistance. There's also a bit here, and I think it's transistors, but anyway. You can also measure resistance with these bottom ones. So, this is incredibly useful. Like if you're testing electronics, you're making computers, you're building circuits, you're soldering something, it's a very handy thing to have on hand. We're going to make good use of it during the lab, and we were playing with simulations of it before. So now the lab setup is going to look something like this. We're going to have some batteries, which we can hook up to our little fake breadboard. More on this in a second. And then you can see we have some resistors poked into the metal here. And so what I can do, if I complete the circuit, as I'm doing, metal touches here. I'm going to set this to measure voltage. And then if I look, all right, that's backwards. It's forwards. All right, if I measure across the two batteries, I see 2.8 volts, just under what I would expect from two batteries, but since there's a load, that's acceptable. Now if I look, these are two identical resistors. You can tell because they have, hopefully you can see the banding, the same banding on both of them. And if I measure across each one, this is where it gets tricky. This gets a little finicky. So I measure across the first resistor, I see 1.3. I measure across the second because I'm on, let's see if we... So it doesn't always complete the circuit as well as I'd like. And I had this working earlier, and now I'm a little frustrated. Oh, had it there for a second. Though I shouldn't have had a reading there. All right, that's all of it. That's half of it. So the back of this. So you can see, looking across the two resistors, I'm going the back of one to the back of the other, which is the same as the front of one and the back of one. I get half the voltage. If I go across just the one, also get half the voltage. And so this is what has to happen. You make contact with the resistor. So in the lab, what we're going to be doing is trying to figure out kind of what happens when you have resistors set up in different configurations. Do the resistances get higher? Do they get lower? And so that's what we're going to try to piece together. So in this case, the resistors, as you can see, I go through one, I go through the other, so they are in, hopefully you know this by now, series. We're also going to try to put them in parallel and kind of just play around and figure out what happens there. Now, it's important to turn these off so that the batteries don't die. By these, I mean the multimeters. All right. coming over here, we're getting to how these things are made. So these breadboards are, so a breadboard is a fancy device that does this. What we're doing is kind of cheap, put it together yourself, and be able to see the bits and pieces that make it work breadboard. So what I have here is aluminum tape. Aluminum, being a metal, is insert adjective here. The adjective you inserted was conductor. Give yourself a pat on the back, because that's the right answer. If it wasn't, then you may want to review your notes, because there's a test on this next week. So I make a nice thick slab of, aluminum tape, basically. And then what I'm going to do is try really hard to peel the back of the tape off. Succeed. Make a little handle, like so, and put this down. Since this is a nice piece of conductive aluminum, if I hook a connector up to this, this whole thing will act like one piece of wire. Except, it only kind of does, and it's not perfect, but it works out more often than not. So we're going to make a set like this. You guys will have some resistors to work with. You'll be able to measure the resistances of the resistors with the multimeter. If we change this thing to measure ohms, so resistance, set it to 2,000 or so, we can take a peek, see what the resistance of this is. This appears to be a 667 ohm resistor. Very nice. Now, I mentioned something about frying resistors, and this is what we do not want to do. So what I have over here is me falling into a chair. I have a nice AC-DC power supply, not actually used by the band, just can supply AC voltage or DC voltage. So it's very nice. It goes up to 20 volts instead of the batteries, which go up to like 3. So if you look carefully here, you can see a smoldering crater, well, not smoldering so much, where I may have fried a resistor earlier. Because this resistor that I have here is, let's see, oh, look at that, barely 1 ohm. Not even, it's like 0.8 it's going down to at a minimum. So this is a very low resistance. Very low resistance means it's not really going to put up much resistance to the voltage I try to put through it. So it's going to get a huge current. Huge current means lots of charge. Lots of charge means lots of energy. Lots of energy means something like, I really shouldn't put my face right into this, but in the name of science, this can happen. Ooh, that was good and sparkly. Oh, God, that smells horrible. And ate right through the table. Oh, God. Did not burn the table. We're still good. Still very hot, apparently. Let's turn that off. A little damaged. Quite a bit smoldery. Now a little holy. But overall, still good. So, anyway. In lab, tomorrow, or the day after, or whenever it is that you have lab and are watching this, we will play with circuits. We will build simple circuits with resistors in series. We will build them with resistors in parallel. We will measure voltage and maybe current if we're feeling fancy. Have fun, everybody.